so far we have 40 or 50 people here. We're expecting approaching a couple of hundred, so that's going to be pretty good, and all of you are very welcome. Now, housekeeping, you will see a chat dialogue or an opportunity to chat on the right-hand end of your screen. Please use it only to send questions, not to say hi to everybody, hello to friends, or make arrangements for dinner later, just please for questions. And I will select questions for the presenters at the end of the presentations. Now, it will be at the end of the presentations because we'll be having Mark Smith first from Universal Closures, and some of the questions you may wish to ask him may well be answered by Michael Fink of z-moulds, who will be coming on second, or perhaps by Sascha Baumanns of Intravis GmbH, who will be on fun at the end. Looking forward to it. Thank you. All right, now we've got three presenters, as I said. We have Mark Smith, who's Technical Director and Senior Vice President at Universal Closures Limited. We have Michael Fink, who's Vice President of Sales and Marketing at z-moulds, who's the Austrian closure and mould specialist, and Sascha Baumanns, who joined Intravis GmbH 17 years ago and works in the international sales department. First up, we have Mark Smith. He will be talking about tether caps in general, and will address issues including the new standard of GME 30.40 and closures associated with those. He is Technical Director and Senior Vice President at Universal Closures, and he says he has a passion for developing products and people. He's responsible for the design, development, and commercialization of the company's product portfolio, and is now in his second spell with them. He previously held the position of lead designer, where he was instrumental in the creation of the Cylon CSD closure, which at the time was the lightest, fastest produced full CSD closure available in the world at that time. And prior to returning to Universal Closures, Mark was head of engineering at Dyson, the white goods company, although I don't think any of their products are actually coloured white, but they're pretty well known for their innovative approach and groundbreaking style and design. Mark, I'm going to hand over to you right now, and we're looking forward to hearing what you have to say. Mark, over to you. Could you unmute your microphone, please?
Good afternoon, everybody. Good morning, good evening, wherever you are. My name is Mark Smith, Technical Director and Senior Vice President at Universal Closures. Rory, thank you. You did a great job of introducing me, so I don't think I need to give any more information on my background. So we can just get straight into the presentation and get the maximum amount of time used. So, closure design, tethering, that's what we're here to talk about. What is tethering? Well, it's connecting, making an attachment. I think we all know that. And I think we probably all know as well where it's come from and why. But in the way of a sort of recap as to how we got here, I'll just quote the Single-Use Plastics Directive. I've abridged it, so it's not word for word, but this is what we're working towards and trying to drive solutions in line with. The directive, EU 2019/904, on the reduction of the impact of certain plastic products on the environment, better known as Single-Use Plastics Directive, or SUPD, so SUP, Single-Use Plastics. It's quite a common industry term now. Was passed in June 2019 and came into force on 3rd of July 2021. Article 6 of the SUPD also sets rules for beverage bottles up to the volume of 3 litres in order to avoid, and this is the key bit, unattended losses of caps or lids from July 3rd, 2024, on it's required to have them attached to the bottle. So attached, tethered, that's what we're talking about. So simply put, we have to create a range of solutions for closures which remain connected to the finish, the bottle. The specifications for remaining connected or tethered is a breakaway force no less than 25 newtons. This legislation is applicable at the moment to single-use products within the EU region, and yet we are seeing proactive movements by the world's leading brands to go further and beyond this, i.e. where legislation doesn't mandate it, they are choosing to bring it in. It's not uncommon to find additional design requirements for tethered closures that seek to enhance the consumer's experience, for example. So, i.e. the brands choose to go above and beyond those legislative requirements, as do we at Universal Closures, in the sole purpose of improving the consumer's experience, but also creating the best possible design that we possibly can. So above and beyond is what we're talking about. I mentioned finishes then. So that's the bottle. That's the actual neck part of the bottle that the closure attaches to. And you may have heard a lot of talk about 3040 or GME 3040. It's the classification of that particular finish. Now, the standard for 28mm neck finish at the moment is 1881. That's the most common finish for CSD water, but of course there are others. It is intended that 3040 be a replacement for 1881. There are shorter neck finishes in the market already, specifically in the form of, say, GME 3037. But there was testing done at Coca-Cola that's shown that this particular finish struggled with some of the more extreme performance requirements, specifically carbonation retention and opening performance. And so Coca-Cola set about with a group of suppliers, namely closure and finish suppliers within the industry, to create a finish which could meet the additional requirements needed. In addition, there was a requirement to create tethered space. So GME 3040 could have indeed been made lighter still, and in fact there is a finish known as GME 3041, which is indeed lighter than 3040, but it doesn't contain the necessary space to bring about tethering. So GME 3040 preserves the bore diameter of 1881, but offers a weight reduction of approximately 1.2 grams through external design optimization and material elimination. So specifically removing material where it's not required on the outside faces of that finish, so the pilfer bead, the thread reconfiguration. And all of those changes were validated through extensive testing in the laboratories of Coca-Cola and Universal Closures with a range of closures to make sure that a new finish for tethering was created that could indeed be the right kind of platform to take us forward. So, can all closures and finishes be tethered? Well, in essence, yes, the answer is they can. The aim when tethering a closure should be to achieve a net zero impact on characteristics such as weight, capping application, manufacture, tool design, and customer interaction. So net zero, I mean, we don't want to create a situation that's worse than what we're currently in by loading up a closure with a tethering system that's got enormous weight to it. GME 3040 is created so that there's enough vertical space to incorporate tethering technology within the parameters of the actual closure itself without going external to the actual closure geometry. There are other finishes like GME 3041 or 2925 or 3037, which don't contain sufficient height within their finish to incorporate that tethering technology. And so it is possible in those situations to tether those caps by creating external geometry. If you look at the simple image on the screen here, you'll see a closure, which is actually designed by Universal Closures for the 3037 finish, which has external straps. Two hinge straps which protrude from the outside of the closure. Now, that particular design is interesting because 3037 is a lighter weight neck finish than, say, 3040, for example. And why wouldn't we use that? Because a little bit more plastic in the closure surely isn't a worse situation than more plastic in the finish. And it's simply because there's other impacts outside of weight. So it's more difficult to apply by the capper. It would be more difficult to manufacture the closure. The tooling design would be more complicated, and the consumer experience would be impacted to a greater extent, i.e. they would interact with their fingers more with those external straps than with a flush design, which you'll see on the slides coming forward. And so it is possible to create a lighter weight neck finish than GME 3040, but you have lots of other upstream impacts that have to be considered. So it's a balancing act between the right amount of size, geometry and weight in the finish and the minimum amount of design considerations you have to put in to the closure design that has other impacts as well. And so that brings us on to a 3040 design that UCL Universal Closures have created. We have many tethering designs and solutions for many different finishes and closures at UCL. I won't go through them all today. I just want to show you two very different ones. The one on the screen you're looking at today we call the Eagle, and this was designed specifically for GME 3040. It's a screw cap design with full CSD capabilities. The design is transferable also to 1881, but other shorter neck finishes would be more difficult to achieve, like 3041 and 3037, because they don't contain the necessary height to build in the tethering space. It was agreed by the group of consultants for Coca-Cola that 2 millimeters was the required difference or vertical space necessary to give everybody an opportunity to incorporate robust tethering technology. Now, Coca-Cola set about a set of additional requirements beyond the mandatory requirements, which covered items such as clearance to the finish opening, which is specifically where the consumer would drink from, repeatable and intuitive opening, and an opening holdback. So, i.e., when the closure was opened in the opening position, as you can see in the large image, it would remain there. And that when the consumer was to use it, it would be intuitive across many different closure manufacturers and suppliers, but remain familiar. And so what you're looking at is our Eagle interpretation of that design brief. As I've mentioned, it's full CSD capabilities, but it also has all of the requirements to meet the Coca-Cola requirements laid down and other leading brands that went beyond legislation. The key part of achieving a tethered closure on such a finish is to make sure that you can raise the closure from its finish before you begin the articulation of the actual tethering. If you begin articulation too soon, then you simply clash with the threads and it's very difficult for the consumer to bring it off. So the mechanism we have within our design is best described as like a scissor lift you would get, where the opening of the band comes away from the shell, you lift the closure clear, and then you can articulate open. That clears the threads and it allows the closure to perform in that way in a repeatable manner every single time, which is really important for the consumer because they need to be able to use this intuitively without instructions and without a manual, and they need to pick up a different closure and not know that it's any different from the one they had from a different shop or in a different country the day before. So the main challenges that we had to overcome here was, first and foremost, it has to be a functioning closure design for the regular set of requirements. So, i.e., it has to be a robust closure in its own right. It has to meet all of the standard requirements that we have for CSD closure design. Then we need to overcome the challenge of articulating that particular closure beyond the finish and the threads and leaving sufficient clearance to the drinking surface that it doesn't interfere with the consumer's experience. And then it must remain there once it's there. So it stays in the position and isn't flapping around. And all of it has to be done without large overhauls to the capping system and cross-closure compatibility. So you're making sure that that closure design can run in as with little modifications to the current capping system as possible. And that's what the Eagle design from Universal Closures seeks to achieve. A very different approach to tethering is to incorporate a live hinge within the closure. And UCL have a design we call hinge molded closed, or HMC for short. Now, this is a simple flip-top closure design. It doesn't work for CSD products because it can't vent the carbonation, but it works really well on short neck finishes like 2925, where beverages such as water and dairy, non-carbonated beverages, are present. The UCL hinge provides a natural tether. It naturally connects the lower part to the upper part. It has built-in tensions within the design that give it a natural spring effect. So once it goes over center, it will come to rest at 180 degrees or greater in its final position. So there's no mechanical holdback, it just stays in that position. Again, meeting the requirements of getting the finish and the closure separated so the user can actually drink without intrusion. It also works really well from an optimization point of view of the tool design, which Michael, I'm sure, will come on to later, because it's molded in the closed position, which means that you get maximum cavitations per tool footprint. The main challenges that we had to overcome for this particular closure, and this is quite a key element of what we've done here, is that it works on an existing threaded finish, so the existing 2925. And if you recall what I said a moment or two earlier, the 2925 is a very short height finish. And so you struggle to incorporate the tethering technology necessary without going external. That's not the case with HMC. We can build it into the height of the closure and use that articulation to get the upper cap away. It's possible on a threaded finish. So you screw the closure as you would normally apply it and it comes to rest. We've innovatively used the threads of the finish itself as the click back features. So there's no singular bead, there's no adjustment to the finish. This is really key because making a conversion from 2925 to a snap bead finish, for example, is an enormous overtaking for the capping lines and the tooling which already produces the preforms on what is already a very lightweight, very optimized short neck finish in 2925. The main challenge we had to overcome here, though, is getting the right balance between opening force, your initial opening force, which needs to be sufficiently high to keep the closure intact when it's in transportation and keep the product intact, but also achieving the retaining force necessary for reseal. So when the closure reseals, it's extremely important that you've got sufficient sealing to retain that product and its integrity. So getting those balances right was the main challenge that we had to overcome here, of course, whilst utilising the existing finish. We had to set about a unique chuck design. It's not elaborate, but it's specific to this closure, but it's fully compatible with the existing capping lines also, which is key. So preserving the finish is really important, and preserving the existing capping lines is really important. So minimum change to achieve what we're trying to do. What we don't want to do with tethering is to create these elaborate solutions which actually have a greater environmental impact in terms of resin or lots of change parts to machines. We need to make sure we maintain the balance of how we change the designs of the closures without impacting lots of other things upstream, as I touched on at the beginning of the presentation. And that's a nice segue, I think, into beyond tethering. Tethering is not the only tool in the toolbox for us here to tackle the ocean waste and sustainability challenge that we have within the plastics packaging industry. It has to be a much more holistic approach. Tethering is part of a package of solutions where we can retain the closure to the bottle, which minimises the chances of those caps ending up in the ocean. They keep the package intact. But there's other things we can do. One of those things specifically being the unification of resins within multi-component products. Universal Closures created a three-piece sports closure, which had an overcap traditionally produced in polypropylene, which we switched to high-density polyethylene. So all three components of that three-piece sports closure were produced in high-density polyethylene, excuse me, rather than a mixture of PP and high-density polyethylene, which creates a problem for the recycling chain where you've got to separate those two particular resins. If we can unify the resin, that simplifies the recycling system. We need to move away from virgin resins, so 100% brand new resin, and start to incorporate PCR resins like those from EcoPrime. UCL has done testing on various closure designs, both in water and CSD, where we have blended these recycled high-density polyethylenes with a virgin high-density polyethylene. In water closures where the requirements are less stringent than a CSD closure, we've successfully blended 100%. So 100% recycled high-density polyethylene in a closure. This eco-prime resin that we used is fully FDA approved, and the key to such a recycled or reused resin is the source in which it comes from, and that source is a closed-loop dairy supply. So at this moment in time, it's very dependent on where you can actually obtain that recycled resin, but once those infrastructures are in place, it'll be a very useful tool in the toolbox to make closures that are not exclusively from virgin resins. CSD is a little bit more challenging. The requirements are much more stringent on a closure. The performance requirements are harder, and therefore it's about 50% blending at our lightest weight CSD closure, which is 1.9 grams at this moment in time. So CSD challenges the resin to a much greater extent than water does, but still we can blend up to 50% with that Eco Prime from Invision Plastics. There's other things beyond that, and I'm not an expert in this particular field, but it's a very interesting field nonetheless, which is bioassimilation additives, which break down the closure, the plastic closure in our case, into a, let me just get some notes on this because I want to be a little bit specific about what I'm talking about. It's a degradation, so it's plastic reduced to its molecular weight that be consumed by microorganisms. It's the final stage of plastic biodegradation, and it leaves no microplastics. So by adding an additive like this bioassimilation to our regular resin, it enables those plastic products to be broken down over a much shorter period of time than is typically the case at the moment. My understanding is that polypropylene degrades at less than 0.5% over 100 years. The claim from this particular additive is that that period can break down to 42 months depending on environmental conditions. So it's a little bit outside my area of expertise, but it's a very exciting field and an illustration that there are many different ways to go about this. There's also another area that I'd like to talk about, and that's returnable plastic bottles. RefPET, I think, is the most commonly used term for this. These are interesting because we're talking about a finish and a closure which have greater amount of mass than the current system. So a much more robust bottle than is absolutely necessary to carry the liquid and meet the performance requirements. But the key part about the RefPET system is that that bottle is only produced once and reused up to 20 times. And therefore, the energy gone into producing the finish in the first place is much, much less over the lifespan of that bottle before it finally gets broken down. It requires a different type of closure. This system is prevalent in Latin America and Germany, but not widespread across Europe. It's an interesting system. UCL have a closure design in HDPE, which eliminates the need for two-part products with a PP closure, for example, with a liner. So a single piece HDPE closure for returnable PET bottles is a very interesting system as well. It requires some infrastructure, but there are countries and regions around the world that have that infrastructure in place. And that brings me on to my final point about improving education and refuse infrastructure where it's most needed. So tethering is a great tool, as I've mentioned, to attack the problem, as is RefPET, as are bioresins and recycled HDPE. But we need more effort, I believe, in education globally so that we can help developing countries with their overall refuse problem. Otherwise, we really are just scratching the surface with our efforts here, and it needs to be a much more holistic approach. That concludes my presentation. I hope you found it informative. Some bits I'm sure you know already, some bits perhaps you don't. But I will hand over to Ruari, who will introduce Michael. Thank you very much.
Okay, Mark, thank you very much indeed for that. That was great. It was really fascinating, and we're particularly interested in the development of the biodegrading additive, because I think that that's going to be a big step forward. But overall, I think that was just great. And thanks very much indeed for your time. You will hang around and answer some questions later, I hope, because we've already got one, at least one, which you'll answer later. Thank you. Now, I'm going to bring in Michael Fink, who has been working pretty closely with Universal Closures for quite some time. He's Vice President of Sales and Marketing at z-moulds, the Austrian closure and mould specialist. He and I actually met in Sydney, Australia, a few years ago when we went to the launch of the Cylon sports closure that Mark referred to in his presentation. Now, Michael is globally responsible for all sales activities of z-moulds, a company he joined in 2005. Before his vice president role, he developed the closure business in emerging markets. So, Michael, have you got your camera on?
Yes, indeed.
Okay, because all I'm seeing is a series of monograms at the moment. That's great. Thank you very much indeed. We're seeing your slides now. Over to you, Michael.
Thank you for the nice introduction. And let me start quickly. We also used a lot of our time in this first interesting talk. And I try to catch up a little bit so we have enough time at the end for questions. So let me shortly introduce the company. I think most of you already know, so just a quick update. Our company in the past years got a lot of growth. Yeah? So this is why internationally I can say today that we already started now also operation in the United States. So we will have sales and service also in the US starting with April this year. And beside that, you can see on our landscape that we are covering pretty much every continent with sales activities and customers all over the world. As Ruari already said, we met in Australia when we did business for Coca-Cola there. So lucky to see you 3 years later again when it's only online, but better than nothing. So what are we doing? We are cap specialists, so we can support designers on the one hand, like UCL, one of our partners, in designing the closures, so developing the closure in a pilot mold, testing the closure in our laboratory, and finally approve it together with the customer to have at the end of the day 100% complete turnkey solution for a new development. We have a big equipped laboratory here where we can do all kind of necessary testing according to whatever protocol you require. And also a capper machine, for example, to do realistic performance tests. What we are known for is our leading technology. We have a couple of patents here. One very well-known patent is the so-called Z-slide system. And the Z-slide system is nowadays already since 13 years in the market, so well proven. And I want to talk a little bit more in detail on that because it's affecting the closure business with tethering caps as well. It's actually a good solution with a minimum changeover cost. So what's a smart way to do tether caps? As we just saw in Mark's presentation, Mark showed two different types of tether caps. On the one hand, we had a 26 millimeter GME 3040 design, so-called 𝐒𝐲𝐬. And on the other hand, the very interesting 2925, which is a hinge molded closure for an existing threaded neck. Very interesting. And I will come back to both of these closures a little bit later. And just want to start now with the molding technology behind. And as I just said, one of our most known patented system is the Z-slides. The Z-slides is a very special system because the Z-slides is differentiating itself from every other technology in this area of closure producing pretty much. Yeah. So on the one hand, when you look on the front of such a mold, it has a completely flat parting line. So there is nothing here in the front which needs to be centered, which needs to center each cavity. That means that when the two halves close each other, then it only closes on a flat parting line. And this is only because we are centering the mold with sidewards guiding bars and nothing on the cavities, as the cavities are on the inside of the mold. So the sliders are not in front of the mold and doesn't need any double centering. They are inside the mold and therefore don't need additional centering. Only the mold halves are centered, and therefore we have very less wear over the years compared to a regular slider system. Yeah, whoever runs a slider system knows that they need pretty much attention because of creating wear on the sliders. Beside that, having the sliders on the inside makes the cavity also very accessible. So each cavity is accessible from the front. You see that here by 4 screws, you can pull out the complete cavity stack. And with the complete cavity stack, you can interchange every part on the cavity, from the core to the cooling top to the stripper sleeve, the sliders, whatever. So you can do everything within the machine. And also the frame that you see here, the 70 millimeter, is the same frame for all kind of closures from 30-25, 29-25 down to 28 or 26 or 25 millimeter nowadays. So for all your molds, you remain with the same size of the mold, therefore the same pitch between the cavities, therefore the same hot runners. So that was just a quick one on the Z-slides, just to recap. So as you can see, the sliders are moving out, and then after ejecting the closure, they are moving back in. So that's the simple movement. So now, what has that to do with tether caps? Yeah, for sure, new requirements come up with tether caps. And as we already saw with Mark's explanation on the design, we have on the one hand a 30-40 design with a hinge here that can give the closure the necessary height in releasing the cap from the thread, or even in this 29-25 millimeter design that has an active hinge. We need to demold lots of different shapes on the side, and that brings in the classical slider molds. And in our case, it will mean that the usual parting line, which we have from the cold half to the hot half, with the sliders on this side, the parting line will move upwards. Yeah? On this design, for example, the parting line is here, and on the 29-25 design, the parting line is at the top of the closure. So the complete closure contour, the complete side walls are within the sliders. And that means you need higher sliders to give it the space to demold these kind of designs. And what we did is we used our existing and well-proven system, and by changing angles on the demolding phase, we could simply increase the height up to a 50 millimeter space, which we can demold a closure. So therefore we can bring, for example, a closure like this here completely on the cold half side. That means we remain with the same existing advantages of having less wear, having the same kind of pitch between the cavities and everything. So that means we can bring up a very flexible system, which you even can rebuild from an existing Z-slides mold to one of the new tethered designs by simply shifting the parting line and extending the sliders. So that means you have one mold size with one kind of cavity stack, compatible from a 25 millimeter closure up to a 33 millimeter closure, and in the height possible up to 15 millimeter of cap height to be completely covered in the slider. And this means that we can cover a right compatibility on all known closure necks like 1881, 1810, 29, 25, 30, 25, and all the 26 millimeters and 25 millimeters. What brings that at the end of the day? We can still remain with our established system, with all the big advantages that were proven in the last 12 years. We can have the same wide range of closures covered in the same size of mold with the same hot runners and everything. And not just with the extended, not just with the extended slider mold. It's the same. It's also, if you, for example, nowadays have a closure with a folded band, where we use our Z-folded technology, or if you have a regular closure with the Z-slides technology, with a regular molded TE band, where we use the Z-slides, or nowadays with the Z-slides extended version for the tethered closures. All these different technologies are completely compatible to each other. That means they have always the same pitch between the cavities, so you can use always the same hot runners. Most of the base platings are the same. You have the same accessories, you have the same cooling system, and mostly the same standard parts. So this also is an important point that Mark covered in his speech, that sustainability also should bring us to a point where we can reuse things also on a mold side, and not heavily invest in changing lines and adding weight and so on. So it's better to use the existing and by simple changes be able to cover also the new requirements. Anything else? Yeah, if you need anything else, then beside the tether cap, also if you're looking for sports closures or edible oil or whatever, just come back to me and I can show you various different designs and solutions for all these closures. Thank you, and from my side, back to Ruari.
Thank you, Michael. That was thanks for that insight into tool making, because I think we're all aware that there are challenges with making the new tethered caps, it's good to know that it's not frightening and not overwhelming. That there are people who are there to help us cope. Right, the third presentation today is from Sascha Baumanns, who's from Intravis Vision Systems. Sascha joined the company in 2005, so he's been with them for 17 years now. Makes him something of a veteran, I think. He works in the international sales department and is an expert for vision inspection technology for the injection moulding branch, I'm given to understand, and especially in Europe, Asia, and Australia. Now, he's focused and specialized on the injection moulding industries and their products, and was deeply involved in the Drinktec 2017 closed loop closure production project. And since 2019, he has been leading the sales team. Now, Sascha, have you got your camera switched on? Because I can't see you at the moment.
Yes, it's on, Ruari. Thank you.
Is it?
Yep.
Okay. All right. I was looking at the wrong one. It was IW rather than SP. There you are. There's your presentation. I'm delighted to hand over to you. Thanks very much.
Thank you very much, Ruari. Thank you very much for the nice introduction. So my topic today is tethered caps need new inspection solutions. So I see now in the chat a lot of my colleagues, former colleagues, but also some of my OEM partners and my customers. I see them from Australia, I see them in the US, and of course here in Europe. So good morning, good afternoon, good evening. So for those of you who don't know me, my name is Sascha Baumanns. I'm the head of sales here at Intravis in Germany. I'm now with Intravis here for more than 17 years. And first of all, I want to give you a little bit an overview about our company, who we are, where we come from. So Intravis was founded in 1993 in Aachen in Germany by Dr. Gerd Fuhrmann. He's the managing director of Intravis. We are making vision inspection system for the plastic packaging industry. That means we develop and distribute quality control systems And we've got a clear focus on detecting process fluctuations and changes at a very early stage. So not like my presentation 2 weeks before, where I also give you a journey, an overview about what happened in the past and what will happen in the future. Here I was definitely tell you about all the big advantage on vision inspection system for tethered caps closures. So where we are located in Germany. So here's our headquarters with sales and service center. Also our R&D department is here and the manufacturing facility. And in addition, we have subsidiaries in the US and in Shanghai, as well as sales and service centers, partners all around the globe. Here are some very interesting facts. We have more than 3,100 systems running in the plastic packaging industry. And believe it or not, every second I present now here for you, we inspect an average of about 20,000 beverage closures for 30 cavity-related inspection criteria, with more than 5 cameras and a high-voltage inspection to detect microholes. So our fastest systems run in an application with 2 injection molding machines and inspect 80 closures per second with 6 cameras plus microhole inspection. Can you imagine? The system has to do 480 images every second and, of course, detect the defect and reject the faulty one. So we heard a lot from Mark and Michael why tethered caps, so I will not argue you or tell you here something about the past or the future, what will come. So just one focus from us, it's we were focusing on both the reduce of littering and an increase of recycle rates for plastic closures in Europe. So what are the solutions? You heard it from Mark that you've got a threaded neck and a snap neck, yeah, for still water application or for carbonated applications. So what are the solutions in the market? Yeah, of course, molded, what we heard before from Michael, but it's also some slitted versions in the market available. So our focus will be to have a vision inspection system ready for both for slitted and folded tethered caps. So as we've seen today, there are already a lot of different exciting and promising design concepts on the market. Some with a clear focus on compatibility with existing production equipment, others with a high added value in terms of user experience. So many of these features are quite new in the beverage closure sector, especially also for us. So the vision inspection system need to have an artificial intelligence to focus especially on the tethered caps feature. So we can help. We've got something to ensure that this challenge does not become a risk. We have taken a look at the entire value chain and we can help to optimize and minimize your risk. What is our solution for this? We start in the beginning now with the CapWatcher Q line. Later on, I want to present you a smart camera. It's called the Intra1. And then later on, I show you some solutions for the filling and capping line. So we're starting now with the CapWatcher Q-line system. Q means the quality lab. We bring the quality lab inline to your production. So whether inline with an injection molding machine or a compression machine, the CapWatcher Q-line inspects 100% of the produced closures. The system is equipped with 8 cameras, an innovative microhole inspection, and as well as our unique temperature inspection. The temperature measurement of each closure in combination with our reliable cavity number reading offers unprecedented possibility in monitoring of the mold. 144 cavity-related statistics will shown every minute to you to improve your quality. Here we see our movie regarding the Intravis CapWatcher Q-line. So I hope you could all see the movie. If not, please give me a call afterwards and I will send it to you directly per email. So in the beginning, you see here the form fitting, a lateral star wheel separation. This is very important that you have a very repeatable positioning of the closure. This is both. It's a fundamental requirement and it's a key. Only if the closures are aligned with high precision, the in-house developed illumination and the inspection concept can unfold their full potential. Yeah? What we can do here, for example, we are doing a measurement of the closures with an accuracy of 0.02 of a mil. So in comparison to our competitors, they are just doing a comparison measurement. We are doing real measurements. And this is a key fact also for doing the Industry 4.0 realization. Furthermore, we've got the non-contact microhole inspection. Why do we need this? It's a highlight of our systems, yeah, that we can inspect, or that we using the microhole inspection where the closures are not in a jam. Here they are singularizated, and this gives you a very big advantage that we also can read the cavity number, and we are putting all the defects in respect to the cavity number, and we are just sorting out the defect closure, not the 3 or 5 before or after. So why it's so important? It's because this micro holes can lead to inconvenience for the end consumer, since a bottle becomes leaky or foreign substances enter the bottle. So whereas conventional microhole inspections still use metal wheels, yeah, to dip into the closure, it making it impossible to inspect the closures with useful features inside, such as reclosing features in the non-contact variant. So the closure slide under the inspection unit without the need for immersion or any contact. This is not only a great advantage in terms of process stability, it's also a hygiene factor. Then we are using 3 cameras for the inside inspection. So there was a large focus is placed on the important functional elements of the closure, starting with the sealing surface, the seal cone. We are measuring, for example, diameter. We are measuring ovality. The closure adds, the thread area, the area between the closure and the tamper evident band, as well as the tamper evident band itself, and all elements such as hinges or locking aids. In addition, the closure is inspected for cosmetic features like black dots, unmelts, burns, and the cavity number is read so that each inspection criteria can be assigned to the correct cavity number in the mold. Furthermore, we've got outer inspection. You see here the closure is hanging on a vacuum belt. With 4 cameras, we are inspecting 360 degrees of circumstance. Plus, we have 1 camera from underneath, from the button, that we can also inspect the outer head plate. This is very important if you have an opaque closure where you cannot look through. Even more, we can also inspect for short shots, for flashes, or worn blades. It can be identified in a very early stage. Here you see the HMI of the system. You see, it will directly display you on one look all of your products. That means this is a closure where we have the inside inspection, the cavity number reading. We've got the temperature sensor. Why are we using this? 3 points we have for this. The 3 advantages. First, that you can do a closed loop relation, because therefore you need to know the measurement. Is this done on a cold or is it on a warm closure? The second advantage is you can define the shrinkage in the mold, that you know directly, okay, a cold and crystallized closure has maybe a final diameter of 28 millimeter. Together with my warm material, master batch, and virgin material, I have to make it maybe 1/10 of a mil hotter with more diameter because of the shrinkage. And the third point is, if you have a blockage in the cooling, the system will directly see it, because then one cavity bench is too hot. And this could be shown by the system. 4 cameras from the side. Further, 1 camera for inside, where we are doing the real exact measurement of seal cone and diameter, and the outer head plate inspection. Together with a micro hole inspection, as I said, 144,000 cavity-related statistic. And here you see the statistic on board. Or if you have an intravisualizer, you can also see it in your office or the quality department or wherever you are. So this was the first solution. This was the Intravis 𝐏𝐄𝐬𝐥𝐚𝐬 Q line. And now we also have the Intra1 camera for the integration in the feeder for the capper. So the system looks like this. It has proven itself for several years in the inspection of closures in the feeding of cappers before the filling process. And whether as a standalone application or integrated into sorter, the Intra1 ensures a smooth filling process and minimizes the risk of cost-intensive machine downtimes. Here you see an application, and with a dedicated inspection setup, the system inspects the closures for deformation, color, and dimensions, all the 3 points which will stop the filling line. The third solution what we have is our 𝐾apWatcher FC for filling and capping, where we are in the discharge area of the filling machine. So its area of application is the inspection of bottles and caps in the outfeed area of the filler after the filling process. It's equipped with 7 cameras and inspect the fill bottles for proper closure fit, the important tethered cap features such as hinges and bridges. Here again, you see the HMI of the system. Here very important is also that we are looking for the application angle, the color, the gap between the cap's tamper evident band and the bottle's neck support wing, and of course the correct fill level of the filled product. So in addition, all inspections are in accordance with CETI quality guideline number 18. That means the 𝐏𝐿 Q line measures the caps with a repeatability of 0.02 of a mil and can reliably determine the weight of the caps in a parallel sampling operations. And with the 𝐏𝐿 FC, it monitors the gap between the TE band and the neck support wing, as well as checking the correct application angle. So you see, with this, it will fit directly and wonderful into our solution portfolio of high-performance inspection system for the plastic packaging industry. Here you see our caps and preform production. That means here we offer the 𝐏𝐿 Q line, the 𝐏𝐿 SC, and the Premon, a monitoring system for preforms. We also have system for resorting and refining. This could be a print watcher for a print on-site on a closure. It could be the Intra1. Intra1 could be used for all of applications in the packaging industry. The pre-watcher offline and offline system for resorting with a speed up to 72,000 preforms per hour. A sample pre-watcher, a laboratory system, which directly inspect all the attributes on your preform. It could be, for example, dimensions, could be dimensions on the thread, E, Q, H, X, and so on. It could be weighing the preform. It's measuring flash on the parting line with an accuracy of 0.05 millimeter. So it turns the preform 360 degrees and one camera is making 60 images only from the thread. And so if a flash appears, the system directly see it and eject the preform. Furthermore, it's also looking with a spectrophotometer on the color of a preform. So it's you want to produce on an edge. Yeah? You don't want to use as much material or as much color as you want because you want to save money. So therefore also the system warns you if you're using too much or too low color. Then we've got a layer watcher. The layer watcher will be used in, for example, coffee capsules or into multi-layer preforms where we are inspecting the layer inside the PET material. And we've got our color watcher lab, a laboratory system directly located at the injection molding machine. You just open a door, put in a preform, press start, stop, and the system tells you immediately if your color is good or not. For the blowing and capping, we've got the 𝐏𝐿 SC, I mentioned a few minutes before. The Intra1, again, a PET watcher installed inside the PET blow molding machine, plus a bottle watcher for extrusion or here for PET bottles. Filling and labeling is a sleeve watcher or a label watcher where we are inspecting inline with up to 10 objects per second for the correct label. And end of the line, our 𝐏𝐿 FC for filling and capping. And all the modules or the vision inspection system works perfectly in connection with our intravisualizer, the unique possibility of cross-site traceability and documentation of the packaging quality in the individual production steps. So this is the end of my presentation. Thank you very much for your time. I see now with all the people that nobody left, so I think it was not so bad. Thank you very much.
Thanks, Sascha. That was great. Yeah, as far as I could see, nobody left who didn't immediately come back. So that's good news. We'll be taking questions in a moment, but before we go, I think it's really an excellent thing that you've done there. You pointed out, or somebody said to me a little while ago, that the most expensive way of quality control is for your customers to tell you that something's wrong. So it's an awful lot better to invest in quality control within your plant before it becomes a problem outside of the plant. So thank you very much indeed for that. And also, the more you can automate, the easier it is to do, and more you can compete with low-cost labor areas elsewhere. Okay, that's good. Now I'm going to tell you, there was a particular question that we had just at the end from Apurva Doshi. He had a technical issue watching Mr. Fink's PowerPoint, and if possible, it would be great to have them emailed, and also Mr. Smith. Well, the whole thing is being recorded, and we'll make sure that the PowerPoint presentations actually appear properly, and if they don't, we'll find some other way of getting them to you. So fear not on that, Apurva, all will be well. Now, going back to the first question, which was back here a bit, Thomas Herkert said there was an unstable line from Ruari. Well, I hope that's got better now, and that you can hear what I'm saying. So, Arthur Lenoir, and this is a question I think for you, Mark. Thank you for joining us. Thank you for coming back. Could you make sure that you've unmuted your microphone, please, Mark? At the moment, it's showing us muted. But Arthur Lenoir is saying, is the HMC design capable of dealing with nitrogen dosing? And if yes, what is its performance like?
The simple answer is yes. So we've been testing that closure to beyond 30 psi pressure retention, which we would do as a standard for water closures anyway. Typically nitrogen pressure internals would be about 15, maximum 20, but should be around about 15. So yes is the answer to that. Okay.
Yeah, is that dealing with the latter part? Oh, sorry, yes, you have talked about the performance. Sorry about that. Yeah, now Thomas Herkert also asks, is EcoPrime a brand name? And I think the answer to that is yes, isn't it?
Yes, it is. Yeah, from Envision Plastics in the US.
Okay.
There will be others, but that's the one that we've used so far.
Okay. Marvin, who came as a guest, said, can these upcoming recycled HDPE materials be used on traditional compression and injection molding systems, and what are the experiences here so far? Now, I know that I actually visited a factory in the East Midlands. It was, oh gosh, I can't remember. HDPE caps, but that's for dairy. So there's two things. One is non-pressurized and one is CSD. So can recycled materials be used on traditional compression injection molding systems, especially on CSD?
Well, I think this is probably one for Michael and myself, but what I can say is that we've produced injection molded closures with the recycled high density polyethylene and found that there was no significant impact to our standard processing. So cycle times are unimpacted. Closure sizing was typically not impacted. There was a very marginal change in bridge performance, so the brake force in which the bridges would operate, but we are talking minor adjustments here. Actually, everything else was on par with what we would typically expect for the processing and production of an injection molded sample. Mike, would you say?
Would you like to add anything to that at all?
I would say at the end of the day, it's depending. The better it's sorted, the better it's the same as a virgin resin. Yeah. Mm-hmm. If you have a mixture of different resins, then also your results will get different.
Well, that's a little commercial for Intravis, isn't it, for Sascha? For make sure your inspection systems are up to the job. Okay. Now, Karen Laird asks, it is my understanding that biostimulation additives are controversial. It is questionable as to whether biodegradation takes place or fragmentation only occurs, adding to the microplastics problem. Now, you and I spoke about this only a few weeks ago, didn't we, Mark? And as far as I'm aware, the one that we were talking about, which was Advantech, that actually is a bio system. It breaks it down all the way down to the original polymer. Is that correct? All the way down to the molecular level.
That's correct, with no microplastics, but I really want to stress this. That's not my area of expertise. It sounds like the gentleman raising the question probably has more than I do, and it's certainly a debate that we should have a resin expert involved in. The key message I want to get across with regards to those types of additives, recycled resin and the like, is that there are more than one ways to attack this problem. Right. And that it is part of a picture. It is emerging technology. We've tested it within the closure production, i.e. we've blended it at 1%. We have found no degradation to closure performance in a CSD closure, so it has passed all of the brand requirements, which are in this case, I won't name the brand, but they're extremely extensive requirements for that particular operation. Regards its actual credentials for biodegradability and environmental impact, beyond my area of expertise, but let's just take away that there are many different companies attempting to tackle this in many different ways, and I think it will be a suite of solutions that get us closer to where we need to be.
I think that's fair. Yes, I'm seeing it in a range of areas that attempts to introduce either biodegradability, if that is such a word, or making more use of bioplastics in the first place, or biomaterials in the first place, is something that people are putting a lot of effort into at the moment. And Karen, yes, I know that you're not a gentleman, but Mark doesn't necessarily see the names.
I'm terribly sorry.
Okay.
I'm going to blame it on your line is breaking up terribly, Rory, and I took a 50-50 guess.
Oh, right. Okay, so it's my fault.
It's definitely your fault, yeah.
Mea culpa. Okay. Yeah, okay, right. Right, there's a couple of people talking about the line quality. Now, Jean-Marc Eloy asked any concern about slitting technology in terms of microplastic particles generated during the slitting process. Now, is that one for you, Michael?
Not really.
Oh.
I rather would prefer to use sliders, yeah, but for sure slitting is also a way to get certain contour in your shell. Yeah, but I'm not aware of microplastic during slitting process.
Okay, now we're coming to 𝐂𝐨𝐧𝐭. I hope I pronounced your name correctly. Now, if not regulated, how do you see the potential of tethered design to be commercialized in the rest of the world? So yes, tether caps are only required currently, or only going to be required currently by law in the EU. Do we see it spreading to the rest of the world? We were looking at it actually originally coming out of Australia again, weren't we, Mark, I think? Are we going to see it in Australia and in America and the rest of the world?
Yes, I mean, I suspect we will. I can't really speak specifically. You're right about Australia making noises in that particular respect. There are differences of opinions in the best way to attack this problem. And if you recall my presentation, I spoke about 3040 and 3041. Mm-hmm. And 3041 will do the same job technically as 3040, i.e. in its CSD performance, but it will have an awful lot less PET plastic within it. And therefore, certain regions may take the view that we are just better off using less plastic and less energy to produce that, and getting the performance and the sustainability impact lowered from that aspect, rather than bringing in a tethered closure. I can't talk specifically, but there are different schools of thought that I'm sort of aware of in conversations that we have. So yeah, I'm not convinced that tethering is viewed as, you know, if you don't have to do it, whether you should do it and whether it gives you the best solution. But what I would say is that, you know, we're clearly leading the way here in Europe in terms of the legislation and the blueprint. And I suspect that everybody will then follow suit. And it works in a similar way, I suppose, with regards to Coca-Cola, for example, and the independent bottlers. And if we're in the business as we are of designing to the most stringent of requirements currently, be it performance or requirements for tethering, then that's what we do. We meet the most stringent of requirements, and then everybody else will take those by default because it sort of trumps everything else. So what I would say is that those requirements are beyond the legislation that we're designing the closures to, and therefore the other regions that choose to take it on will acquire them naturally. So that's the best way I think I can answer that.
Okay, so it's going to be, in a way, it might be legislation that does it, or it might be the big brands like Coca-Cola, Pepsi, whoever, will actually lead it and drive it for reasons of corporate social responsibility.
Yes, absolutely right. Yeah, consumer behaviours and the like. Yeah, and that's why it's going to be such an interesting time to see how this does in fact take off within Europe, to see how those behaviours are adjusted, if you like, because another part of the puzzle is consumer behaviour. You know, purchasing behaviours, recycling behaviours, and the like. So yeah, I think we really have to watch what happens when we see it sort of integrated. But if we can't crack it in Europe, we're going to struggle to crack it elsewhere.
Absolutely, and I agree, and I understand. And somebody I was speaking to called Mike Schiavone of R&D Leverage did make the point that actually one of the biggest problems that we have is the infrastructure for collection and recycle and educating people on their behaviour. Michael, you're nodding vigorously. Anything you would like to add to that?
No, I see it the same way.
Okay, that's fine. Okay, now we've got Apurva Doshi, or Doshi Apurva. I'm sorry if I'm not 100% right on the name. Now, in India, we mostly have Alaska 27mm closures and preforms, and also a lot of non-standardization in preform neck dimensions. So Apurva is expressing a concern with regard to tolerances in the tethered band, especially with regard to water closures, because water is pretty big in India. Yeah, it's a bit difficult to design for non-standard closure systems, isn't it? And for people who are going their own way. Anybody like to pick up on that, or have I just answered the question?
Yes.
Right. Okay. That's.
But I mean, as a glimmer of hope, maybe there are certain systems that are better at dealing with those variances than others, and just going slightly off piste here, UCL have a blade design sealing system which we developed exclusively for extrusion blow molded finishes. So typically there's a polypropylene cap with a liner that's inserted into that particular closure. That liner's job is to take out the variability and the general roughness of a guillotined extrusion blow molded finish. Now, the problem with a liner is it's two component, and you've got to separate those two things, but you've also got to produce the two things, and you've got to assemble the two things. So UCL created a single piece high density polyethylene closure which has a blade seal. Now that blade seal works in such a way that it mimics the behavior of a liner without having to insert a liner, and it has such a range of accommodation that it can take out that variability or accommodate that variability in the extrusion blow molded finish. And therefore you can clearly see the benefit of that particular system where we've deliberately tackled the variability problem. It's a little bit different to what's being asked, but it's an illustration that it is possible through intelligent design to accommodate that variability. And of course, the key element of that particular closure is that it's single piece, but it's also the same material as the extrusion blow molded bottle. So the whole thing goes back into the recycling chain without need for separation, without separate components. And you can see the clear benefits of taking another step in the big picture, I say, in the right direction. Just briefly on say if the variability was in the pilfer bead, then I would say that a folded band system had a greater capacity to deal with the finish variation in that area than a molded undercut band, because the way that it folds up on the inside, it's much more mechanical, and that it will find its natural biting point, whereas a molded undercut system is sort of fixed in terms of the diameter and very finely tuned to work with those tolerances. So there are design tools that we can use to take out that variability if that's a major concern.
Okay, and Michael, how easy is it to design tools to make things like the bladed cap?
Yeah, the blade seal is fantastic. Yeah, it's really innovative closure design to get rid of liners. From a tool point of view, it's I would say also very interesting to do it, but also challenging. Yeah. So we have the first tools running, which is good, but that's just the start.
Okay, but yeah, it's certainly an interesting development, and anything that takes material out and makes things easier to recycle is all to the good, I would have thought. Okay, Martin La, is there a tethered cap for PCO 1810 on the market? Martin La asks, is there a tethered cap for PCO 1810?
We have not specifically designed one. I can't say if there's not one on the market, but what I would say in answer to that is we've got several tethering design solutions for screw caps, 28mm screw caps. So we have already transplanted the Eagle design that I shared on the screen from 3040 into an 1881 closure, and it's translated extremely well. It would translate equally well into an 1881. Sorry, an 1810 finish, but the Eagle is sort of the bells and whistles design that we have. So it's got all of the sort of functionality that meets the requirements of Coca-Cola. You don't necessarily have to go to those extent to meet the legislative requirements. So we have much simpler lasso type designs, which would probably be very applicable for an 1810 closure that you could incorporate very simply into the existing shell. So the answer is not specifically for us. Others may be, but if it was required, we could do it fairly easily. You know, we've got various design designs that would translate well to that platform.
Okay, that's fine. Thank you very much indeed. This looks like the last question, and it's an interesting one, or I think it's interesting. Christian Straka asks, do z-mould and United Closures see noticeable differences in the quality of master batches on the tethered closures? And do certain colours act differently in the moulding process of tethered caps? And are there differences with different colours? And are they big or marginal? And I think that that's a question for all three of you, because it's a quality control question as well.
The first thing I want to say is that we are Universal Closures Limited and not United Closures. That's a different company. Please don't confuse the two of us together. I'm sure United are very, very good, but they're not here today. It's Universal Closures today. So right. just to say that, because I had to. And the question, maybe I've talked enough. Maybe somebody else can take the answer.
Michael, it's an issue with the tools, the sort of viscosity and the flow rate. We've got a handsome apology mark with the viscosity and the flow rate when designing the tools or when making the tools perform. Have you come across any problems with master batches in that way?
I would say the influence of the master batch is not really bigger than it was before. So if you had a master batch before that was having a big influence on shrinkage, for example, then it was also a bad master batch for a tethered design. But if it was, let's say, not really a big difference to not using non-master batch before, then it also doesn't have the big influence on the tethered design. Yeah.
Okay. What about from quality control? What's the Intravis view on different master batches and different colors?
That's now an easy one, because I can just agree what Michael said before. I mean, what we figured out, it's absolutely now it's the same. So we have now several systems in the market, and if it was untethered or not tethered before, it's of course, yeah, it's influencing as you have different master batches, different materials, and this you will also see in the tethered closure. So at the moment, it seems like they are similar.
Okay. All right, well, that's all the questions, and that's all the present. Oh, hang on. We've just got another question popped up. First of all, Kay Muller yes, there is a chance to see a recording. It will be available on the PETplanet website in a couple of days. Marvin has popped back up and says, I believe it's been mentioned earlier, but could Intravis give any information on the maximum inspection speed when working with 1881?
So actually we can go up to 80 objects per second, of course, depending on the design of the closure. If you have more knurls on the side, for example, it could be that they are sticking a little bit more together. Yeah, than if you have a flat circumstance, but actually up to 80 objects with up to 6 cameras. So in total, 480 pictures would be done every second.
Now that's faster than your average movie, and that's pretty quick. Thank you very much indeed. Okay, that's the end of our presentation today. I would like to thank all of our presenters, Mark Smith from Universal Closures Limited, who's joined us from Tewkesbury in Gloucestershire, Michael Fink, who I think has joined us from Austria. I'm not part of,
yes.
Where are you, Vienna itself? Or
no, in other side, Dornbirn.
Right,
By
okay.
Constance.
Okay, and Sascha?
I'm in Germany, in Aachen, very close to Cologne and Düsseldorf, where the next K show will take place. So very close. So you are all invited to come and visit our booth. So I hope to see you all there.
Okay, and I'm talking to you from Salisbury in southern England. So thoroughly international and very inclusive. Thank you all very much for your presentations, and thank everybody for joining us as well. It's been a good audience and we've had some good questions and a great session, I think. Thanks very much indeed. Goodbye.
Thank you.
Thank you.
Thank you, everyone.
Bye.